Hi and welcome to this video about DLL injection with Windows hooks. Now the term hook is highly overloaded, but in this case I'm talking about Windows hooks available with this function called SetWindowsHookEx, which allows us to inject the DLL into a target process, or in fact even all the processes that are attached to the current desktop based on the threads that create UI using that desktop. In general, we can target a particular thread or all threads in that desktop, in the current desktop that we're working with. And the only main, I would say, downside of this technique is that it requires the usage of user32.dll in the target process. And this is used for UI stuff. So if we're talking about a process that has no user interface, this kind of technique will not work. And so in order to do that, in order to inject DLL using this technique, we need to do some things such as create the appropriate DLL and have some kind of hook function in that DLL and then invoke the appropriate hook. The actual loading of the DLL into the target process is done by the Windows infrastructure. So here's the example I'd like to demo you. What we'd like to do is to hook some kind of thread which belongs to a process, let's say something like Notepad or something else, and every keyboard message, every character being typed, for instance, in that Notepad instance, I would like to transfer back or to notify my controlling process, the one performing the injection, of these keystrokes. So here's the basic architecture. We have some target process we're targeting. We have our injector process, the one that's going to initiate the injection. And what we're going to do is to load our injected DLL first into our process. This will be necessary to initialize some information, as I'll show you very soon. And then we're going to call SetWindowsHookEx and target the thread that manages the user interface in that target process. Usually there's just one, but could be more than one. It really depends on the process in question. I'll talk about that a little bit once we start the coding demo. And then we'll force that DLL to load into the target process using the SetWindowsHookEx API. And then, of course, there should be some kind of way to communicate with the injector process so that every keystroke can be transmitted somehow to the injector process. And the way this works behind the scenes is that all these hooks are based around messaging, that messages that arrive to the message queue of the thread managing the UI. You can watch the Creating a Basic Window video to get a better sense of how messages work. And so messages would come in, and messages of interest, such as keyboard messages, should be transmitted to the injector process. So that's the idea. Let's see how that would work in practice, at least one way of doing that. So I have here a Visual Studio project I created. In fact, there are two projects here. One of them is the executable, that's going to be the injector. And then there's also a DLL. Currently what I did is just create a barely empty project with some initial code, very fundamental, you can do using a wizard. In the DLL case, we have just a DLL main with some empty code here. And in terms of the injector, there's just a main function with this includes. So I'm going to start with the injector and then we'll fill in the details or fill in the blanks with the DLL. So the first thing we need to do is to grab the process ID. So if we don't have enough parameters, then of course we have a problem here. So let's just use some kind of usage here saying that if you want to inject, you need to provide the process ID. In this case, I'm just going to use the DLL as a hard-coded DLL for this purpose. So now that we have that, we have the process ID, we can grab it. So let's take the process ID by looking at the parameter on the command line using the simple A to I function. And what we need to do now is to find the thread that manages the user interface in that process, if any, in order to perform the hooking, because the hooking is based on thread IDs and not process IDs. And so what we need to do here is to find some thread ID. So let's do something like this. Find UI thread and call this function given the process ID. We need to build that kind of function. Of course, it doesn't really exist. So let's go ahead and do that. We want to return the thread ID, and that's going to be called find UI thread with correct casing. And we have a process ID that we need to work with. So essentially, we have to scan all threads that belong to this process. We could do that in several ways. I'm going to stick with the documented way, which is to use the tool help APIs that I demonstrated in an earlier video. So what we're going to do here is to create our snapshot using the function create tool help snapshot 32 or 32 snapshot. In this case, I'm going to have snapping here threads. And unfortunately, there's no way to actually be more specific than that. I might want to provide the process ID here. It might seem that I actually can because the function does require process ID, but in fact, it only makes sense and only works when enumerating modules and heaps within a given process. For threads, we always need to specify 0 here. That will provide all the threads in the system. So if that fails for whatever reason, it's going to return invalid handle value in this case. There's nothing for me to do here, just return 0. This is unlikely to happen unless the system is totally out of memory. Then we need to create this thread entry 32 structure, initialize the size of that thingy, the size of the structure. This is required. And in the previous video, long time ago, I've shown you how to enumerate processes. This is essentially the same idea, this time with threads. So we're going to start with thread 32 first to get the first thread from the snapshot. Now, technically, the first thread is one of the idle threads, so we definitely don't care about that. We can go ahead and go over the loop using thread 32 next and getting the next thread in line. So let's get it. As long as we have more threads, we'll be part of that loop. So the first thing we need to do is to make sure that we're talking about the process in question that we're interested in. Only for that process, we need to grab a thread ID. So how do we do that, since we eventually will get to that process, if that process indeed exists? The first option, the simplest one, is simply to return that thread ID and that's it. Because we know that in most cases, the first thread is the one handling the user interface. If we want to do something slightly better, we can use the function getGUI_thread_info. And this function returns information about the thread ID and its GUI capabilities. And so you can see here the function requires something called GUI_thread_info. GUI_thread_info, let's define one of those. And in fact, we have to initialize the size of the structure with the first member there to the size of the structure correctly. And then we can use the thread ID that we get here in the enumeration. This is the one. And look at the information that is returned. The actual information is not really important, but if the thread in question is not a GUI thread, then this function would fail. So we can move on. But if it returns true, it means it is a GUI thread. So we'll just grab the first one. Let me just put here the thread ID in some local variable and just break here out of this loop, if this is indeed the case when we find that thread ID. So let's define that here, starting with 0. If we get it, then great. Otherwise, we can move on to the next one. And then finally, we just need to close the snapshot handle and return whatever TID is. If all goes well, it has some value that is obtained here. If not, it will just return 0, which is going to indicate some kind of failure. So if we get our thread ID here, if that's 0, we can say something like no GUI thread found. It could be because the process ID is garbage, or because the process itself doesn't have any GUI at all, so there's no GUI thread. Once we have that, we can move forward. And moving forward is something we need to do in order to load our DLL. So what we need to do here is not just call SetWindowsHookEx, we'll have to call that for sure, but in fact we're missing some parameters here. The first thing we need is a type of hook, and there are several types of hooks that are supported. It's not just one, there are in fact several you can use depending exactly on what you would like to do. But for our purposes, what we need here is something called getMessage, which essentially means that every message arriving at the message queue of the thread in question, we would like to inspect it first and be able to look at that and even change that. That's also something that is possible to do. Then we have the function that we need to call, and that's the missing piece here. The module is also something we're missing because it's supposed to be the handle to the DLL in question where the function is. And then we have the thread ID. So So the thread ID, in fact, is the only thing that we do have here in this particular call. So we can definitely specify that, but we're missing some things. So let's try to fix that by getting the missing stuff. So first, the DLL itself, we need to load it. Let's call the load library function. And I'm going to assume here that the injected DLL here, which is our other project, is going to be in the same directory, which is indeed going to be the case. But otherwise, it is possible, of course, to just use a full path here in some way. And that handle to DLL is, in fact, this parameter we need to specify here. So that's the module handle, or the address, or virtual address where the DLL is being loaded. Now you might be thinking, what does that mean really? Because we're loading the DLL into our process at this point, not into the target process. So that is correct, but we have to start somewhere. The DLL will also be loaded into the target process once we call this function here. But the other thing that we're missing here is the actual hook callback that should be called for every message that's being posted into that target thread message queue. So how do we get it? So what I'm going to do, I'm going to assume here that there's a function, let's call that hook func, that is available as an exported function from the DLL. So I'm going to call the function get proc address to ask DLL, please give me a function that has that kind of name. Let's call it whatever we want really, because then we'll have to implement the opposite thing in the DLL, of course. Let's call that hook func. In fact, the type here is called hook proc, my bad. Just cast it so the compiler is happy. We're going to get that function here and just pass it as is. So this is what we're going to do here. I'm going to get back a handle to hook. So a handle to a hook represents that connection. That's going to be hook func here. So if that fails, we get null here, then obviously something went wrong. Maybe the function doesn't exist in that DLL or whatever, so we can't really use this right now. We can say error in SetWindowsHookEx and just bail out early. Not going to do any kind of fancy error handling here. The next step, once we have that, in fact, we're essentially good to go. Once we do that, the hook is going to be installed when the first message arrives. So what we can do in order to force it, we can call the function post thread message and take the thread ID that we're targeting and just send it a null message, which just doesn't mean anything, but will force the message queue to be active, which will force Windows to load the DLL into the target process address space. So once we do that, we have the DLL loaded, hopefully, in the target process address space, and we're essentially done. But of course, not quite. There are a few things that are still missing. First, we're talking about DLL itself. What is that DLL supposed to be doing? We need to implement this function called hook func, which we promised it would be there. In fact, we probably have to, maybe it would be nice to actually check that. If that doesn't exist, then of course, we can say that function not found, so we can't actually connect to this function. So we can do that even before trying to call SetWindowsHookEx. So obviously we need to implement that function, but before we get to DLL, there's another thing we want to do. We want to be able to get notifications of keyboard messages, and the question is, how would we do that? We know that we can use various inter-process communication mechanisms to get notifications from one process to another. In this case, I'm going to use, in fact, messaging. I'm going to have a message queue in this thread, and I'm going to use the pumping messaging loop using the function getMessage, simply getting messages, and I expect these appropriate message to be coming from that target process from my hook function. This is what we're going to use here. We're going to use messaging as inter-process communication mechanism. It's just one way. We could do different things, such as using COM or maybe doing named pipe or something. There are multiple ways of doing that, but in this example, I think since we're in the spirit of messaging, let's just use messaging for this as well. And so what I'm going to do here, I'm going to use some custom message here. So if the message is going to be, let's call that WM app, which is one of the values we can use for custom messages, which are not going to be taken by Windows, then we have something here that we actually can get. And this means we can now do something with this message. Let's assume that the actual character that was hit by the other application is available in the wparam parameter, in the wparam member, which is one of the custom members you can have in a message. So let's just display that in some way, like so. Let's just take message.wparam. Let's assume this is where it's going to land. And essentially, that should be good enough. If the wparam happens to be something like 13, which is essentially the carriage return, let's also move to the next line to make it slightly better in terms of how we display stuff. So this is, if it's this message, let's continue pumping these messages as they arrive, and only when wm quit is sent, then get message will bail out. We can exit our application. We can even be nice by using something like unhook Windows HookEx, unhook Windows HookEx to really remove that hook, although of course when the process dies out, the hook will also die out normally, I would say, but still it's nice to always clean up properly. So let's also call a free library here and we're done. But we're still missing a few things. How come the DLL will ever send us messages? It needs to know the thread ID of our thread. So maybe that other process can call post thread message. So how would we tell the other process or our DLL that we have some kind of ID we would like to share? So we'll get to that. But before we do that, let's first build this application, make sure we don't have any errors. So you can see we have some error here. That's not too bad because it's supposed to be an integer. Since it's just a character, let's just do that so the compiler is happy. Main should return, must return some value. Yes, that's right. Okay, fine. So everything is good until now. Let's move over to the DLL, see what we have to do here. And so we should expose a function that has the prototype of hookproc. That's what we have to provide here. You can see hookproc looks something like this. We can go ahead and just copy paste or go to documentation, copy paste from there. So let's write this function. It should look like this. So we have here callback is just the std call, meaning the standard calling convention. The function name could be whatever we want. In this case, we decided on hook func, so let's just stick with that. So we have this function here available, and we need to, of course, implement that in some normal way or some appropriate way. So here's the way this works. This is, of course, fully documented. We have some kind of code which indicates what we're supposed to do. In this particular type of hook, if we get this code called HCAction, which simply has a value of 0, it means we should be doing something here. And what we're going to get here, if you look at the documentation, is that the lparam parameter here is actually going to be a pointer to the message that we're supposed to be looking at. So that's the actual message being passed to the target window procedure, but before it arrives there, we have a chance to look at that and even change that. And so what we want to do here is look at the message. There could be dozens of messages. We're only interested here in this message called WM character, meaning some kind of printable character has been pressed or something that is identified as something like that has a printable or sometimes non-printable like carriage return, but something that is a combination of keys or key that has been properly pressed. So if we get that, we'd like to send that information back to our original application, which is the Injector application. So we want to send that to that other thread. So we need to have the Injector ID here somewhere. Let's just use some dummy variable at this point, and then the message itself should be WM app. This is the value we decided upon so that the client can coordinate and look for that particular message. We decided to go with something which is not used by Windows by default. And then we can send anything we want in these two parameters, and we decided wparam is going to be the actual character. And as it happens, the wparam of the message that is received, in fact, contains the actual key being pressed. So we can go ahead and pass that, and we can even pass the lparam here. There's no harm in doing that, or simply passing 0, even though we're not actually using that value in our other application. And once we're done with that, we can go ahead and call the call next hook ex, which is passing the message to the next hook in the chain. Because there could be more than one, it's considered polite to let the other hooks that might have been installed here to get their own chance of running some code. And the handle to hook here, in fact, can be null. It doesn't really necessarily have to be the actual hook handle. And the code, of course, is just going to pass whatever I got here to the next hook in the chain. So the only thing we're missing here, at least at this point, is this ID. So we need to have some global variable here that's going to be this ID, and obviously it has to be populated somehow. So what we're going to do here, we're going to expose another function. Let's call that set and notify TID. And this is where we get the thread ID from somewhere at this point. Let's just use the standard calling convention as well. That makes sense for 32-bit. And then we'll just go ahead and put that in our global variable. So at this point, of course, it's unclear who is going to actually call that. And that someone is going to be our calling application. So let's go back to the executable here. So we know that we're supposed to have some kind of function here as part of the DLL, but we have to bind to it dynamically. So let's do that in the same way that we've done this binding to this hook function. So I'm going to do auto p set notify TID. Let's cast here now. I've defined or declared the function prototype here to make it easier to perform the appropriate casting by using DLL type here for set notify. So it's kind of easier to do that using DLL type without having to actually define a type there for a function pointer. But if you prefer to do that, you can. So if you're familiar with function pointers in C, it's a bit perhaps not very fun, but it's doable. So you can do something like this. And that would work in essentially the same way. That would be the actual type, something like this. But I would recommend against it if you're using C++ 11 or later, because you can use DLL type and it's, I think, more elegant, is less error prone. And if the prototype changes at a later point, still it will not be necessary to change anything here. So we have this DLL type, and then we can call getProc address again, have the DLL handle, and then the function is supposed to be called set and notify TID. That's what we decided back in our DLLs. And if that works, then we can call it with our thread ID. So get current thread ID. So the messages will be targeting our thread here, the messages targeting our thread back here. So that's what we're trying to do here. We're trying to tell the DLL that it's supposed to send messages to this thread. Now you might be thinking something here might be fishy because I've loaded this DLL into my process, the Injector process, and then I'm calling a function here to store that as a global variable in my process. How would it get to that other process, the target process where the variable is actually needed? And so what we're going to do here, we're going to share memory using a trick that I've shown in a previous video, using a data segment or a section within the code. I can give it any name that I want. I just need to provide initialization here for variables, use a pragma, another one, to close this data segment, and then I need to tell the linker that I'm going to define a new section in the PE that's going to be called .shared, and it's going to have the shared property. So this S actually is the key to the whole thing. So once I write it in my process, we're actually going to be showing up in the other process because they're going to share this particular section as a separate section in the PE. So we expect the value there to be available once everything is in place. If we do that and we build, well, it built successfully. I guess that's one good thing. Now, when the DLL is loaded, we have DLL main here, and DLL main is being called by in multiple scenarios. In fact, one of them is when the DLL is attaching to a process, like in this case here. But there's also the opposite case, when the process DLL is detached from the process. For example, our target process, say notepad exit, so the DLL is detached. So perhaps it's a good idea at this time to send a message to our injector with a WM quit message so that we can exit that loop and not be stuck in that loop forever. But that's just a nicety that we can have. It's not strictly necessary. Okay, so are we done yet? Are we really ready to go? Well, almost. The only thing that is missing is that these functions look like normal functions, but they're not really exported. We have to export them, and one way of doing that, to export them as C functions, is to add a module definition file. So I'm going to add a module definition file by looking for def, so there it is. We're going to give it the name injected as the same name of the project. This is by default as it will work. We need to write the exports that we have here. So we have one export, that's hook proc, or here hook func, sorry, and then that's the other one, set notify at TID. So we expect these two to be exported from the DLL, otherwise get proc address in our injector has no chance of succeeding. So this get proc address would simply not work. Okay, so now we're ready to test it, I think. So here's a Notepad instance here that I have, and let me go and open Task Manager here to look for this Notepad process ID. So we have 33216. Let's go ahead and work with the debugger here just to see exactly what is happening, at least in most of the code paths here. So let's go to the properties of the project, go to the debug XCC4 configuration, go to debugging here, and then write, well, I already forgot the process ID, 33216. So let's do that. And now we can put this project as a starter project, which already is. We can go ahead and press F9 here and run this. And hold on to your seat or whatever you have there. So let's see, argc is good. So now we're getting the process ID, which should be the correct one. Let's switch to decimal values, 33216. Great, let's see if we can find a UI thread. I'm not going to dig into this function. Let's see what we get back. And we get something, 78692. In fact, we can verify by going to Notepad here in Process Explorer and looking at the threads. We can see that the first thread here, which in this case just the only one, has this ID 78692, which is handling the UI. So we got the right thread to work with, at least that's what that looks like. Let's now load the DLL. Would that work? Yes, it does. I should be doing some error handling here, but it worked. What about the hook function? And it exists, so great. And then we also have the notify function. Does that exist? Yes, we find it. It's exported properly. Then we can send it the current thread ID. Great. Now we are going to install the hook. Let's see if that works. So we get something with hhook, which means the hook is installed. We can trigger that message to actually load the DLL. So if we do that, we can look at Notepad here. And if you look at Notepad, here's injected.dll just came up into this process, which is a good sign. So now we have here our console application, the injector, and then we also have our Notepad. What we expect to happen now, I think I pressed F5, I did. So we expect at this point that keystrokes here will be mirrored in our application. Let's see. Hello world. Yes, it seems to work just fine, right? Okay, not bad. So let me close Notepad here. And we can see that WM quit message is arriving, in fact. And one other thing we can do here is play around with that. So for example, we can go to our DLL and decide, for example, that maybe we want to prevent certain messages from reaching the application. So for example, let's say that the W param here, the actual key, let's say the key is something like, say, I don't know, H. Maybe you don't like H for some reason. Then we don't want that to reach the application. The way to do that is to change the W param to something like 0, which indicates no key really, and then the message will go over to Notepad, which of course will cause this to fail. So now we can try it again. Let's this time go ahead and try this with a command line without actually having to use the debugger here. So let's go to x64 debug. Let's launch another Notepad here. So here's a Notepad. So here goes, and of course we need the process ID. We could add code to actually search for Notepad, but in this case I'm going to leave that as an exercise for you. So that's 86868, a nice number. So we have injector here, injector 86868, even I remember that. So here goes. Let's go here and try to do things. Let's try to write H. We can't write H. I'm trying to write H, so small h works, but if I do Shift H, that doesn't work. Of course, we can prevent a capital H from working as well. So this is SetWindowsHookEx.